Lesson 8.10, Applications Using Rational Expressions. So at this point, we have simplified rational expressions, we've added them, we've subtracted them, we've multiplied and divided them, and we've solved equations using rational equations. Now we need to solve real-world application problems. And one application problem that can be solved using rational equations is a distance problem with currents. So you have air currents or water currents that either work with the vehicle or against it. So take, for example, if we have the Mississippi River and there's a paddle boat, the Creole Queen, traveling 4 miles upstream against the current in the same amount of time it takes to travel 6 miles downstream with the current. And if we know that the current of the river is 2 miles per hour, we can determine what would the speed of the boat be if it was sitting in still water. So the way we want to solve this is we're going to use distance is equal to rate times time. This is the distance formula. So we have distance equals rate times time. Okay, and the best way to set this up is to go ahead and make a chart. Okay, so we have upstream and downstream. Okay, we have the distance, we have the rate, and we have the time. Okay, in this instance, we don't actually know. Oh, yes, we do. Sorry, 4 miles. We're going to go 4 miles upstream and 6 miles downstream. Time will be the same each time. We don't know what that time is, but we know that the time is the same. And when we're going against the current, so if you go against the current, then you do rate minus the current, because you have to subtract the current because you're fighting against it. If you go with the current, you're doing rate plus the current because the current is actually pushing you along, so it's adding to your rate. So upstream is against the current, and the current of the river is 2 miles per hour. We don't know the rate of the boat, but we know when we're going against it, we're subtracting 2, and when we're going with it, we're adding 2. Now, in order to solve this, what we have is the distance upstream is 4 is equal to r minus 2 times t, and the distance downstream is 6 is equal to r plus 2 times t. Setting both of these equal to t will be our first step. So if I have 4 is equal to r minus 2 times t, sorry, this should be in parentheses because it's a solid expression. I need to divide both sides, not by t, but by r minus 2. And I'll have that t is equal to 4 over r minus 2. Or I have 6 is equal to r plus 2 over t, or times t. So if I divide both sides by r plus 2, I get that t is equal to 6 over r plus 2. The t's are the same. That means that 4 divided by r minus 2 is the same as 6 divided by r plus 2. Because the time is the same no matter what. Also, it can be helpful when you're making your chart if you do that. D equals RT, just a side note. Now that we've set this up, we need to solve it. And in order to solve a rational equation, we make sure each side is simplified, which in this case we are, and then we cross multiply. So I'm going to do 4 times r plus 2 is equal to r minus 2 times 6. So I get 4r plus 8 is equal to 6r minus 12. If I subtract 4r from both sides, I get 8 is equal to 2r minus 12. And I'm just going to bring that up here because I'm running out of room. Add 12 to both sides, and I get 20 is equal to 2r. Divide both sides by 2, and r is equal to 10, and that would be 10 miles per hour. And this is the speed of the boat in still water. Okay, if we try another one, we have the current of a river is 3 miles per hour. A boat takes the same time to go 12 miles downstream as it takes to go 8 miles upstream. Okay, so we're going to make our chart. We'll have upstream and downstream. Up is subtracting, down is adding. We've got our distance, we've got our rate, and we've got our time. And distance is equal to rate times time. Okay, 12 miles downstream and 8 miles upstream. Our current is 3 miles per hour. So we're going to subtract 3 on the upstream and add 3 on the downstream, and it's the same time. So T is equal to T again. So for this upstream formula, I'll have distance, which is 8, is equal to r minus 3 times t. And here I'll have 12 as my distance, is r plus 3 times t. And I need to solve each of those for t, because t is the same in each example. So here I have t is equal to 8 over r minus 3. And here I'll have t is equal to 12 over r plus 3. And so I want to solve this by setting these two equations equal to each other because the t is the same. And to solve this equation, I cross multiply. 12 times r minus 3 is equal to 8 times r plus 3. Distribute the 12. 12r minus 36 is equal to, distribute the 8, 8r plus 24. Subtract 8r from both sides, and I get 4r minus 36 is equal to 24. Add 36 to both sides, and you get that 4r is equal to 60. Dividing by 4, I'm going to get that r is equal to 15 miles per hour. And this is the speed that the boat would be going if the water was still. Okay, now we have wind speed, and wind speed is the same as a current. You can have a headwind or a tailwind. A headwind is going against the wind, and a tailwind is going with the wind. A headwind is the wind is blowing against the head of the plane. Tailwind, the wind is blowing against the tail of the plane, so it's pushing the plane faster. So in this case, we do r minus the current, and here we'll do r plus the current, and the current being the wind speed. so we have a plane traveling 885 miles against the wind in the same time it takes to fly 1,035 miles with the wind. Okay, so I know, again, that I need to do a table where I have distance is equal to rate times time. And then I'm going to have against and with. Okay, my distance against the wind is 885. My distance with the wind is 1035. My rate is 320 miles per hour. Speed of the plane is 320 miles per hour. But I have, again, a wind current, so I have minus C and plus C. My time is still T, because it says, again, same time. So for this setup, I'd have 885 is equal to 320 minus C times T, and 1035 is equal to 320 plus C times T. I'm going to solve each of these for T because T is the thing that is the same in both equations. So I'm going to divide both sides by 320 minus C. So I get 885 over 320 minus C is equal to T. And then again with the 1035 is equal to 320 plus C times T. I'll divide both sides by 320 plus C. And the reason I'm doing that is because these will cancel each other out. So I get 1035 over 320 plus C is equal to T. This T and this T are the same. That means this expression and this expression are the same. So I'll set those equal to each other. Okay, I need to cross multiply. So I get 1035 times 320 minus C is equal to 885 times 320 plus C. Distributing my 1035. So 1035 times 320 is going to give me 331,200 minus 1035C is equal to, and then I'll do 320 times 885 because I distribute there as well, here and here, 283,200 plus 885C. There's a C there. Okay, so I'm going to subtract 885C from both sides. And I'm going to get 331,200 minus, okay, so now since the 1035 and the 885 are both negative, I add them together, and I will get 1920C is equal to 283,200. Don't be intimidated by large numbers. It's the exact same problem, same steps, it just has big numbers. So you end up with negative 1920C is equal to negative 48,000. Divide both sides by negative 1920. And you're going to get that C is 25 miles per hour. And again, this is the speed of the wind. And that makes sense. That's another thing with the distance is rate and time problems. If you're solving for rate, the rate should make sense. So for example, if you're solving for the rate of a person walking, you should never get 70 miles per hour. If you're solving for the speed of an airplane, you're not going to get 10 miles per hour. An airplane can't fly at 10 miles per hour. A person cannot walk 70 miles per hour. So the numbers should make sense. So think about it and make sure it makes sense. 25 mile per hour wind is normal. That makes sense. 225 mile per hour wind, a plane would not be flying in that. That's a tornado or a hurricane. It doesn't make sense. So then you would want to check your work. Okay, here's another boat example. I'm going to draw the chart for you, but then I would like you to pause the video and fill out the chart and solve the problem, and try to do that on your own. When you're finished, you can unpause the video and check your work. So we've got distance is equal to rate times time, and then you'll fill out these boxes, set up the equations, set them equal to each other after you solve for t, and then solve them from there. So pause the video and then come back when you're done and check your work. Okay, check your work. You should have gotten that the speed of the boat is 8 miles per hour. And if you wanted to, you could go back in and plug in 8 and find out how long that would actually take. Just as a side note, you could put 20 is equal to 8 minus 4 times t. So 20 is equal to 4t. So t is 5 hours. Just if you were curious, you can always also solve that. But you didn't have to. You were just asked to find the speed of the boat in the still water. So check your work. See how you did. Okay, let's try this one. Again, you want to draw a table, and you want an against the wind or current and width, distance equals rate times time. Go ahead and set this up and try to solve the problem on your own. And then when you're finished, come back and unpause the video and see how you did. Okay, now that you've had a chance to work out the problem, check your answer. You should have gotten that the speed of the plane is 110 miles per hour. If you did not get that, go back and check your work. Here I have solving for t for against the wind. Here is solving for t with the wind. And then here is the equation to find the speed of the plane. Okay, so I showed you the table method. I'm going to show you one other method that may work for some people that are maybe a little bit more visual, and that is to draw a picture. So what I do is I actually draw a boat. Okay, and it can travel 8 miles per hour in still water. If it can travel 15 miles per hour downstream, 15 miles downstream, in the same time it can travel 9 miles upstream. Okay. T is the same. This is plus current. This is against the current. what is the rate of the stream. So sometimes for some people the picture is a little bit better. So moving this way, I get that 15 miles is equal to 8 plus c times t. And using this part, I get that 9 miles is equal to 8 minus c times t. Solving each of these for t, I would get that t is equal to 15 over 8 plus c, and t is equal to 9 over 8 minus c. And so I'll want to set those two things together equal to each other, and then cross multiply. Then I need to distribute, so 15 times 8 is 120, minus 15c, 9 times 8 is 72, plus 9c. I could add 15c to both sides if you like them positive better, and I'll get 120 is equal to 72 plus 24c. Subtract 72 from both sides, and I get 48 is equal to 24c. Divide both sides by 24, and the current is 2 miles per hour. So that's one other way to set this up. Do the same thing with the airplane. I've got a plane. This is my stick figure airplane, and it can go 320 miles per hour. Flying with the wind, it can go 1,400 miles, and that's with the wind. Flying against the wind, it can go 1,160 miles. That's against the wind, and the time is the same. We want to find that wind speed. So going with the wind, 1,400 is equal to 320 plus c times t, and against the wind, 1,160 is equal to 320 minus c times t. Solving those for t, I will get that 1,400 over 320 plus c is equal to 1,160 over 320 minus c. Cross multiplying. Okay, then I have to distribute 1,400 times 320. Again, we're going to get some large numbers here. Don't be afraid of the large numbers. The steps are exactly the same. Okay, we'll add 1,400 to both sides. Sorry, 1,400c. And I'll get 448,000 is equal to 371,200 plus 2560c. And then maybe I'll subtract 371,200 from both sides. And I will get 76,800 is equal to 2,560c. Divide both sides by 2,560. And I'm going to get that the wind speed is 30 miles per hour. So this is just another way to set it up. I think the table is nice because it keeps everything organized and makes the setup easy, but if the picture works better for you with and against, that works as well.